So this is the Node talk. My name is Tim Caswell. I run a popular blog about Node called howtonode.org. And this summer I worked at Sencha and built some open source Node libraries to connect and helped with Express. And this is Ryan Dahl, the creator of Node itself. And we're going to co-present this presentation. So just to get an idea, how many of you have heard about Node? I guess that's why you're in here. How many have used it? You? All right. So we're ready to start. First of all, what is Node.js? Node.js is a set of bindings to V8 that allows you to script programs that do I/O. That seems really generic, right? You take JavaScript, you add some interactivity, and you get Node, and it's focused on performance. And that really is, at the core, all it is. It can do anything. It's mostly used for web servers, but you can use it for pretty much anything that accesses I/O. You can use it for other servers, you can use it for clients, you can use it for shell scripting. It's more like a general purpose programming language. But again, it has this focus on performance. So here's the website if you haven't seen it, nodejs.org. And it's got some example web server here and documentation. It's a really good site. Here is the GitHub page for it where the code is actually hosted. And let's see, this was screenshotted a little while ago. We're up to 3,700 followers on GitHub. And considering, when did you start this? Last spring? 2009? So it's not even 2 years old. The interest has been phenomenal. I think people have been waiting for server-side JavaScript that is fast. So it's really taken off. So just to help you understand what different speeds in servers can mean, this is two other servers. This is from a post on a hosting company that switched from Apache to Nginx. This top graph is how many requests per second and how many concurrent connections. As you see, Apache falls down as the concurrency gets high. On this graph, the amount of memory used and the amount of current connections, Apache goes up and Nginx stays flat. Who knows what the difference is and how they're architected?
Process works?
Actually, Nginx is event-based. It doesn't use blocking I/O. Whereas Apache is threaded, or depending on which build you have, multiple processes. So either way, it's a thread or process per connection. But when you have 3,000 concurrent connections, that doesn't scale very well. So there's this really good blog article that I recommend all of you should read. And there's this excerpt from it that I found really interesting. When the CPU has no work to do while it waits, well, when it has no work to do, it waits. So reading from the L1 cache is like taking a piece of paper off your desk. Reading from the L2 cache, and these are caches in the CPU itself. This is really low level, really fast stuff. It's like picking up a book from a shelf. It takes 14 seconds. Reading from the main memory is like taking a 4-minute walk down the hallway to get a Twix bar. So you see kind of the relative speed of fetching data from different places in the computer. Okay. Later on in his article, he says, well, to continue with this analogy, waiting for the hard drive is like leaving the building and roaming the earth for 1 year and 3 months. Who would ever wait while you're waiting on some guy to roam the world for over a year? You wouldn't wait on that, would you? Yet we make computers do it all the time. When your code blocks on a file access, the CPU is doing nothing. And he gave some estimates here. So 3 CPU cycles to pull from the L1 cache, very efficient. To pull from the disk, well, more like 41 million cycles of doing nothing. Now, modern operating systems help by having multiple processes and threads, and it does other stuff in the meantime while it's waiting. But all of that context switching adds up. So it's not a good model if you have a whole bunch of clients. And of course, network is even worse than disk. So Node draws a line. You noticed here, 3, 14, 250, 41 million. That's a pretty big jump. And so Node says anything below that line, we consider that blocking, and we don't block on that. That's bad. We give it callbacks. In JavaScript, it's all callback based. So that your main CPU just has one threaded event loop that just runs. And whenever it hits something slow, like access the disk, it'll say, all right, here's a callback, let me know when the data's off the disk. And that one thread can do other stuff. And so it scales really well. So Ryan's going to go through and write just some sample node programs so you can get a feel for the API.
Hi, so I am Ryan. Right, so what I want to do is a couple of examples. I just have to figure out how to use this for a second. Yes. Okay, so first of all, let's print out hello world, right? So this is like a command line program. So you have node, oops, you have to spell it right, of course. And so you have node on the command line. If you type it without arguments, you get this, this little REPL. So you can do like process.version. Process is kind of like window. It's kind of this global variable everywhere. You have process. Process.version is the version of it. You can print out all the things in process. Anyway, we're not really concerned about that. Let's first print out hello world. So what I'm going to do is just open up everybody's favorite text editor and print out hello world, which looks like that. So hopefully you guys, being browser people, I assume, can interpret what console.log means, since you're familiar with Firebug and whatnot. So that should print out hello world. So node, oops, not CSH. Okay, hello world, yes. Good. So let's modify that slightly. So what I want to show you is set timeout, which is just like the browser set timeout. You give it a callback as the first argument, and as the second argument, you give it some milliseconds, right? So if I give it 2,000 milliseconds, it should wait 2,000 milliseconds before it calls that thing. And what I'll do is I'll put the world in there. So what do you think this will do? You.
Read word after 2 seconds.
Okay, which comes, hello and then world, right? Because it goes right through the set timeout. Set timeout is not asleep, and prints hello and then world. So let's try that. Right, quit and node temp x.js. Hello world, and then it exits. Yes. Okay, so it kind of works. So interestingly, it exited after. Is exited actually the past participle of exit? It exited. It has exited. I don't know. Node has this property that when there's nothing else to do, there's no callbacks pending, that it just exits. So it was done with that set timeout, and it's done. If we had, say, changed that thing to a set interval, then it wouldn't exit because it's got stuff to do, right? Okay. Control C, and it's done. Oops. Hold on a second. Okay, so that was example 1. So that's not totally interesting. What I'd rather do is build a little web service. Hold on just a second. Yes. So Node is about doing networky things, right? So ignore those slides. So it can do DNS resolution, right? So let's just look and see what that might look like. There's a built-in module, which you call with require DNS, which does DNS lookups, as you might imagine. And the function is called dns.resolve. And so you can do something like yahoo.com. Hopefully we have like internet access. You should. Okay, so what you do is you have to give it a callback. Now, live coding is always slightly painful, so bear with me. So resolving an address, I mean, it takes some time, right? It's like Tim said, it doesn't happen immediately. I mean, a lot of APIs kind of make you think that it's just going to happen right away, but as you saw, this could take millions and millions of clock cycles. You're pinging some, if it's not in the cache locally here at this hotel, then it has to go out to the next server, and this can take some milliseconds. And so we don't wait for it. We give it a callback, and we say, okay, continue going on with the operation. Continue doing whatever you're doing. I mean, in this example, we're not going to be doing anything else, but we allow the program to continue while it's resolving this DNS, this domain name. So we give it a callback, and usually these callbacks in the first parameter is this error argument. Like if the DNS address didn't resolve, you get an NX domain or something, then that error object is filled in with whatever error happened. Usually though, it's going to be blank. So kind of a common thing to do is just test if that error is there and throw it. Otherwise, we can just console log addresses and print them out. And let me just put in resolving yahoo.com. By the way, please interrupt me if you would like. Okay, so let's run that. Okay, well, it happened very quickly, right? There you go. 1 million clock cycles, tens of millions of clock cycles right there. I mean, that's the problem though, right? Is that we as humans can't really perceive, 2 microseconds, right? It happens very, very quickly. But in a server, if you're handling many thousands of clients, shutting down the server for several milliseconds is not acceptable. The computer operates much faster than we can perceive. Yes, that happens very quickly, but if you're doing a lot of those things, that kind of waiting for that to happen adds up. Okay, so Node can do DNS lookups. It can print out hello world. It can do set timeouts. That's good. It can also do web servers, which is great because web is kind of useful. So what I want to do is combine this DNS example with a web server and just kind of show how you can kind of mash together APIs and make like a DNS lookup service. Okay, so back to the slides now. So what we want is we want a server that when we curl it, the local host at port 8000, and then put in a domain name into the web server, that it's going to give me a response that is a DNS server. This would be awesome. No, it's super boring, but it will demonstrate a point, and then we'll get something cooler. So let's do this. I'm just going to modify that example here. So in addition to the DNS library, I need the HTTP library. And I'm going to delete that, and I'm going to start an HTTP server by doing create server function. And so we give it a callback. I'll talk about this in 1 second. Let me just type frantically. Okay, and let me just comment this out. Okay, so, right, so we're requiring the HTTP module. We're starting a server here, and we're binding the server to a port. We give a callback, and the callback is executed every time there's a request to the server, okay? Not every connections and requests are not like in one-to-one correspondence. But every time there's a request to the server, this callback is made. And then we do stuff, okay? So, for example, we can respond and write the head, respond with 200 OK, and then we can end the response with hello world. So, that look good? Okay, so let's try this. We bound it to port 8000. We gave it this callback. Let's see if it actually works. So, right quick, node thing. Oh shit, okay, oops. So hard not to cuss while doing this. Forgive me. Localhost, port 8000. Hello world. Okay, now we have a web server. Okay, let's look at those headers. Okay, so how's that look? Content, connection keep alive, transfer encoding chunked, 200 OK. Why is it transfer encoding chunked? HTTP nerds? Anybody in here an HTTP nerd? I assume you people work with HTTP. Raise your hand if you work with HTTP. All right, so why is this transfer encoding chunked? Yes, sir.
So the content.
Exactly. So we had this API. So he said we couldn't set the content length. So we haven't actually told it how much we're going to stream. We could have put in a lot more sort of. The server doesn't know the size of the body that it's going to respond. All it knows is that we're sending some body, and because of that, we use content length chunked by default. So I mean, you can put in any number of writes and start the server, and you'll get back that many things. So it's kind of it's a streaming web server. Hold on a second. Okay. So for example, you could do this. Put a set timeout in here. So, or let's make this better. Let's put one of these writes there. Okay, so what it's going to do is going to say hello world, wait 2 seconds, and then some more hello world. So the node doesn't know how long your body is. Therefore, it has to be a transfer encoding chunked. Let's try that one. Curl it. Hello world, 2 seconds. Hello world, hello world. Okay, so it's a streaming web server, but not stupidly streaming. By which I mean, when we kind of run this thing, and we like run, wait, let me copy this. Copy. And do that, and then do that, and then do that. Like, they all kind of run, right? Like there's no problem handling multiple connections here because we're not actually like shutting down the web server while we're waiting these 2 seconds. We're just kind of doing this event loop thing. We basically tell the kernel, please wake me up in 2 seconds, and the process goes idle. You actually don't need to know so much about that, which is good. So what we should do now is change that set timeout into a DNS resolve. Okay, so first of all, let's get somebody's querying this and they're doing query web server / yahoo.com, right? And so let's pull out that path. So I think you do request URL, like the request URL would be the query. Except for it kind of has this leading slash. So let's take out the slash. So replace slash with, now you guys are like JavaScript experts, so you probably know how to do this a lot better than I do. So let's see here. Hopefully I get this right. But basically, instead of doing yahoo.com, let's replace that with query. And instead of printing it out to the console, let's just do response and JSON stringify addresses. How's that look? Nods, blank faces. Somebody's snoring over there. Okay. So let's try that, yahoo.com. And, oh, great, it worked. What happens if we put in like a bad address here? Or the whole thing crashed. I guess that's not really so good, actually. Why did it crash? It crashed because we had this line here, right? If error, we just throw it, and so the whole server dies. So instead of doing that, let's do something slightly more intelligent, which is test if that's there, and if so, like print out the message. There it is. Something like that, right? And let's add like a new line here. Does that make sense? So now we're kind of responding properly to all these things. So let's start it again. And over here we can curl it. Now we get NX domain, or E not found, domain not found. And if we get yahoo.com, we get that. And if we get google.com, we get that. Isn't this fun? Joint.com, we get that. Okay, so DNS web servers, very exciting. Second. So, are there actually crickets? Okay. All right, so let's just do something really bizarre now. Okay, just freakish experiments when you have when you're able to just kind of make servers. Okay, like mash things together. And my point is not that you actually want to do this because this is totally stupid, but that it's useful to be able to mash servers together. I mean, generally, we as programmers working in the web industry are kind of writing little proxies all the time, right? We kind of take in web requests and we access some database or we hit some memcache server or we talk to something over there or multiple things and we kind of get it back and then send it back over there and we're basically kind of shuffling data around. And so Node is trying to hit that sweet spot of being a good API for shuffling data around. So Tim said it could do anything. Maybe that's theoretically true, but I would say it excels at certain things, right? Possibly not writing SETI at home would be the best, is not the best thing. Not big computational tasks, but shuffling data from here to there. And in particular, shuffling data from here to there in ways that you can develop very quickly, right? Obviously, you can write a little C server that performs much better than this, but this you perhaps can throw together much more easily. So here's what we're going to do. It's totally crazy. But we're going to make a little TCP server that you can telnet to. And you're going to it's going to say when you connect, it'll say hey, wait a second, wait for a request. And then in the same process, we're going to have a web server. So we're going to have a TCP server and a web server in the same process. And when you connect to the TCP server, and then somebody connects to the web server, everything you type in the TCP server gets streamed to the web server. Okay, it's going to be fun, I promise. Okay, so let's get over here, open up our thing, let's start a new one. Blah. Okay, so require net. That's for our TCP server. So net, you can create a server, and instead of being a request-response pair, you get a socket.
What does net stand for?
Network. No comment. For example, if you do socket.end, and you might notice that these are kind of the same methods that were on the response object, but if you do socket.end and say goodbye, and you start this server on port 8000 again, just that right there, then if I start that thing, I'm going to create a new tab, so don't let this freak you out. Okay, blah.js, oops, spelled it wrong. Okay, so now I can telnet localhost 8000, and it said goodbye, and then close the connection. Okay. Like I said, boring, but. So instead of doing that, let's do this. Let's put an HTTP server on here too. Well, I have a point here. This is not totally masturbatory. My point is that thank you. We can kind of put a lot of I/O into a single process. Okay, so let's put in our old response 200 and end. Hi. So now we have something listening on port 8001, something listening on port 8000. And it's in the same web server, in the same process, okay? So we're on an event loop. We're doing only non-blocking I/O, so we can just kind of handle all of these things at the same time. So just to make this totally obvious and boring, let's do that and curl it. 8001, bye. Telnet, goodbye. Got it? Yes. We're just going to do this for the rest of it. Okay. Okay, so now what we're going to do is we want to connect that guy to the other guy. Okay? They're guys. They're masculine. I don't know. Okay, so I'm going to create an array of sockets. And when somebody connects, I'm going to go sockets.push socket. Just kind of store it in there. Instead of saying goodbye, I'm going to, instead of ending it, I'm going to say like, hey, wait a sec. And then it's just going to hang there. Okay, let's just try that briefly. So if I tell that to it, it says, hey, wait a second. Nothing else. Okay. That socket is kind of waiting in that array. So now what we want to do is connect it to this other guy. Okay, so when somebody connects for a request, we're going to grab a socket off of that array, off of that sockets array. And we're going to start taking data from the socket and put it into the response. So sockets shift. Now we get the socket off of there, and when there's some data on the socket, we're going to write that data to the response. Seem reasonable? So anything that's typed on the telnet session will go to the curl session. Remember, this is all streaming. Our web servers are no longer bound by content length. We can actually stream things. So let's try that now. Going over to our tab and doing that. Okay, oh wait, no, so now I'm going to need to have more tabs. Okay, so I'm starting this one, starting a new tab. Macintosh, terrible. So if I tell that to it, it says, hey, wait a second, blah, nothing's happening. And now I curl localhost 8001, which is our web server. I get nothing, but hopefully if I type here, it goes over there. And if I end it, no, then it doesn't end over there. Okay, so that's not so good. Let's fix that. So what we have to do is the event that happens when the socket is closed is called end. And then we're just going to go the end. Okay? That makes sense? This is in our web server, by the way.
Let's not lose the data at the beginning, too.
What's that?
Let's not lose the data at the beginning, either.
Oh, let's lose it for now. We don't want to buffer. What if somebody connects and then starts typing like a huge 20 megabyte file, and then our memory just blows up? Okay, so we start the server again. We go over here. We telnet to it. Nothing's happening. We curl to it. Now it's coming over here. And now if I control weird and control D, it ends and it says the end. Yay, it works. Okay, so this is all much more easily done with the little API sugar that we've added, which is socket.pipe response. So we can actually delete those events. That's what pipe does. And it pipes all the data coming out of socket into the response. So like Unix pipes. Everybody likes Unix. Nobody hates Unix. Unix is there's nothing you could hate about that sort of API. So again, let's try that. So like I said, it works. Yes. So there's a small problem here, which is that what if somebody connects to the telnet server and then disconnects before somebody connects to the web server? It's going to be in that array still, and then somebody's going to connect to the web server and find that they've got this dead object, basically. So whatever, screw that. You can solve it. It's actually it's in the slides. So here's how you would do it. You would just kind of wait until you get one that's not closed. but whatever. You can look at, well, we'll put these slides up on the internet or something later. So what I want to do, because we probably don't have an infinite amount of time, is, oh, okay. Oh, yes. Let's relax then. So let's do a chat server, okay? And hopefully somebody, that guy's got a computer, maybe other people have a computer, and maybe we can like actually do a real chat server here. So what I want to do is sorry. Okay, open that. Okay, so vim/temp chat.js, how all projects should start. Okay, net require net. Oh, by the way, I should tell you my IP address before we start. It is here. I'll put that in my, so, there, oops. Everybody, oops, okay, that's long, huh? Okay, so, net create server, function, socket, typing so fast, it hurts my fingers. Okay. Does anybody have any questions while I type frantically here? No, okay. Welcome to the chat, whatever. Okay, now again, let's have like an array of people. It's just called sockets people, because basically that's what they are. And it go people.push socket, just like we did before. And then now every time somebody says something to their socket, we want to kind of broadcast that to all the other sockets. Okay, so let's try this. We're going to just loop through the people. So Tim was telling me this trick earlier. I think you do like 4 each or something.
Yeah.
Fancy. Now how do you get your I?
It's the callback.
Okay, so
Oh, there's no I. The I second counter if you need it.
does this make sense to you? Let me use the singular. And let me call this data. Does this make sense to you people? You JavaScript, you of JavaScript knowledge? Okay. So we're going to broadcast it to all the other sockets. Okay, so let's try this. Let's start it. Oh wait, wrong one. Node temp chat JS. Oh wait, it didn't. It just exited. So what did I do? I think I forgot to put the listen there. So I have to do s listen. I have to bind to a port, right? If node exits if there's nothing to do. If you don't bind to a port, the server can't accept connections. Okay, so we listen on port 8000. So now you have the port and the IP address. I'm about to start the server, so get ready. Okay, welcome to the chat. Oh, no new line. I should fix that. Hey. Okay, blah. So I'm getting my own things echoed. Echo. Okay. So if I also tell net to localhost 8000 and I say, hey, then it goes to the other one, which is cool. That is cool. Okay, but it's kind of lame actually, because we don't actually want it to echo to ourselves, right? So we should kind of make this a little bit better and say like, if person does not equal socket, like that or something, then we echo it. So that prevents you from sending it to yourself, right? Okay, so let's just do that. Control C. Notice that thing died. Okay, so welcome to the chat. Oh, we forgot to fix that part. Okay. Hey. Yo, yo, yo. Okay, so now it's not echoing, not echoing. Nobody else is connecting. You guys are making this so boring.
No,
It's not working? Oh, no. Terrible. Oh, yes, it is. Yes, do that again. Okay, so let's fix this a little bit more because that person is going to crash it, because actually what's going to happen is if I disconnect, from this, okay, let me show you the node server if it hasn't already crashed. So it's running right there. If I disconnect, and then that person writes something to the node server, they're going to try to write to a socket that's already disconnected. It's going to throw an error, and the thing's going to blow up. Magic happened. There. Yes, broken pipe. Okay, so that's kind of bad. So what we should really do is loop through those people and make sure that they're all writable. Okay, so a socket is writable if it's still connected. It's not writable if it's not connected. Blah, blah, blah. Okay, so if person doesn't do that, and this is the crappiest socket, thing ever. Person is writable. Okay, so that means that they're still connected. So now we actually have a proper chat server. Instead of just writing the data, let's write like a little identifier about the person.
And make a new line after the...
Oh, thank you. And spell it correctly. For God's sakes. Okay.
What's the IP again?
The IP is here. Okay, so also let's write like a little, I don't know, like a little thing like that, so it looks not super lame. And in addition to that, each of these people, comes from an IP address, right? And they all have a port associated with them. So let's just print their like remote address or something. Person.remote address, like that, so that we kind of know where they're coming from. Hopefully we're not all like natted and they're not all coming from like the same address, but let's see. So if I start it now, and we connect to it, we get welcome to the chat. And if I go over here and connect, I go, hello. Okay, localhost says hello. And if I go down to the bottom one, I say, yo, then it does that. And
Someone else?
Yeah, still failed.
No, it's not now.
all right. Well, whatever. You get the point. You can mash stuff together. So here's all the code, which you'll be able to see later. And now Tim is going to talk about higher level things, because this is all very low level. Obviously, you would want to build libraries on top of this to actually do work.
All right, thank you. Okay, so you see Node is very flexible, very powerful. Now who wants to write a web server with logging, cookies, sessions, and all that at this level? Come on. No one? Well, you're in luck. Sencha paid me over the summer to do that for you. And Connect is the result. So it's basically middleware, there's other terms, but basically it's functions libraries that you can layer and take Node HTTP servers and add logging, and add sessions, and add cookies, and add these various things that are very common in web development. So right now there's a GitHub page, and it shows some example usage. There's a ton of documentation here. TJ Holloway-Chuck helped me do this, and he wrote all the docs, so it's great. So here's the hello world of Connect. You'll notice this looks a lot like the hello world of Node. That was on purpose. When I was designing this API, I wanted it at the simplest case to look just like Node's HTTP library. So that once you know that, learning this is easy, but just add more. So instead of requiring HTTP, you require Connect, create server, identical to Node, request response, identical to Node, write the head, I'm setting the content type, and I'm saying hello world. I'm listening on port 8080.
When do you actually know where all the libraries are? That was actually my question before.
Okay, so the built-in libraries are actually in the Node executable itself. They're embedded in the binary. And ones like Connect, Node has library paths, and Node Package Manager that Isaac made, you just install things with that, it puts them in the path, and it's basically like Gem for Ruby or whatever for Python, I forget what it's called. Easy install. But the required, you can actually go to our REPL, let me show you. All right, this is my laptop, I should know what I'm doing. Oh, I killed the chat, I'm sorry. All right, so require, really? All right.
It's changed.
There, I'll get back on the stable version of Node. So this NVM is something I wrote just a little bash script that lets you install multiple versions of Node and then switch to them, which is great when you're testing. All right, so now we're in the stable branch of Node. So whenever it looks for a library, it'll look there first and then look there. And this is where npm will put the library, so connect is in there. Yeah, it's all based on paths.
Are those libraries shared objects or is that JavaScript?
Most of them are JavaScript. You can write them as well as binaries. Node supports either kind. So you can write C extensions that expose stuff to JavaScript and then require those in Node. But all the ones I write are JavaScript because I don't know much C. So again, this looks like HTTP, nothing fancy. But here's the good part. Suppose I wanted to have logging. So Connect has a bunch of middleware built in, connect.logger, and it's just the arguments to create server just layers them. So now every time someone hits the server, you'll get an Apache style log on your terminal that says this IP address with this user agent hit here, the response was this, blah, blah, blah. And that's all you gotta do is say, I want logging. You don't have to write the 50 lines of code to do that. And a really, really common use case, since Node is your HTTP server, it's not an Apache module, it's not an Nginx add-on, it is the server. How many servers want to serve static files for all of your awesome front-end code? You know, like maybe SenchaTouch. How are those getting to the phone? Well, your HTTP server has to serve them. So there's a static provider middleware, you give it a root, and it'll serve all the files relative to that root. And it's pretty fast. And the best thing about these modules is you can just replace any of these with a function that you define if you don't like the way I implemented it. The static provider, for example, does not stream. It takes the file, reads the entire file in the memory, and then spews it out to the browser, which is great for small files, not so good if you're serving ISOs, because all that's in RAM on your server. But whatever, this guy in the community made one that uses Node's experimental send file support, and will actually read it off the disk and using the kernel level send file, stream it to the browser. Extremely fast. If he can just take this line, swap it off of his library, good to go. It's modular. So here's just some examples. This is a page from my blog, howtonode.org, and I'm teaching JavaScript in this article. Here's some objects and the things. This article got featured in Rewrote Web, so I got a ton of traffic recently. But the point is, this entire blog engine is written in Node. See over here on the right where it has revisions? The backend data store to this is not a file system or a database, it's a Git repository. And so whenever you load a file, it does all these sub-processes to git show this revision, this file, and the Git will spew out the contents of that file at that version. And Node has this sub-process API where you can open a child process, hook up its standard in, standard out as pipes, and stream data back and forth. So then it takes all these various sub-things. This is actually from Graphiz, which is a graphing library. It'll open that in a sub-process and convert the Graphiz source files, which is what's in my blog, just .dot files, and render them as PNGs. I didn't have to draw this graph. I just typed some code in a .dot file. And then, so it takes that, it takes all these revisions, it takes my layout. I use Haml for the views. And then it takes all these various files, but since it's Node, it does as much in parallel as possible. It's loading these things at the same time as loading these things, and all your I/O waits are in parallel, and the page loads are actually pretty fast. And also, since it's in Node, I can do really smart caching. It's just one long-running, single-threaded process. And all of these revisions, if you click on those, it'll load that article at that git hash. Well, I know that content will never, ever change. And so in my caching logic, I can keep a hold of it as long as I want to, and never have to worry about invalidating it. A general-purpose web server can't do that, because it doesn't know what the back end might do. When you control the entire stack, you can make these assumptions that make it very fast. So that's one example of a full web server. This is built on top of Connect. If you go to my GitHub, under github.com/creationit/wheat, it's the source to this blog engine. This is another one I wrote. We had an event recently called Node Knockout, which was a 48-hour contest to make cool Node apps. And I was a judge, so I couldn't compete, so I made this for fun. This is a real-time, tile-based, whatever game engine. I'm throwing a couple more buzzwords. But basically, you pick your tiles here. You have this infinitely scrollable map here. You just scroll around the map. You pick a tile, pick where it goes. Now the cool thing is, the entire thing is real-time using WebSockets. So if another person goes to that website, they'll see the tiles appearing as you're placing them. And this is built on top of Connect and Socket.io, which is a really good library for abstracting sockets. It has fallbacks for pretty much every browser in the world. It'll either use XHR or iframes, or if they have Flash, it'll do Flash WebSockets. It falls back to pretty much anything. And it just integrates in as another handler on top of the Connect HTTP handler, and they mix together great, because after all, Node is just callbacks and functions. I didn't have to write any code to integrate with Socket.io. So that's Connect stuff. TJ, who co-authored Connect, had this library called Express.js, which is even higher level. Because most apps, you can assume you're going to want logging, you're going to want sessions, you're going to want cookies, you're going to want to serve static files. You shouldn't have to type those 5 lines every time. So what Express does, how many of you use Sinatra from the Ruby world? A few? It's basically the same thing. So after requiring Express, you left that line out, you create a server, and then say anything that hits this URL pattern, here's the handler. And it's the verb and the path. So if you want to handle an HTTP post to /foo, you say post/foo. And if there's parameters, you just put parameters there, and it'll give you those in your parameters object. It's a nice high-level application framework. And he even has some examples of doing this with an MVC in his examples folder. If you want a full-on Rails-like stack using Node, you can just go through the Express samples, and TJ has an example in there. So again, since it's based on Connect, this server works like the Node server. You just listen. There you go. You got a server running. So again, here's another Express. This is the same one from the screenshot. But here you go. It's easier to read. I want to get anything that hits root and say hello world. Anything else, it'll give a 404. Because you have to handle all that explicitly otherwise. And if there's an error, it'll render a nice 500 page with a stat trace. It's great.
So get maps to the get method in HTTP, right?
What's that?
Get maps to the get method in HTTP.
Yes.
How would you add a custom method?
I don't know if you can, but Connect supports pretty much, it's based on top of Connect's router, which is one of the Connect middlewares. It supports, I think, every HTTP verb out there pretty much. I keep getting pull requests to add new ones. If not, it's open source. It's JavaScript. You can monkey patch it on the fly.
By the way, extension HTTP methods are the devil's work, I would like to remind you. And you will burn in hell if you use them. So please stick to the 4 common ones.
Yes, the spec is evil enough on its own. Trust me. Go read through it for fun. All right. So, and this is an example of one of the Node Knockout competition entries that uses Express. It was called Scrabbly, now it's called Word2. Do you hear they formed a company or something? Someone told me that they got funding to make a company out of this. I don't know. It's pretty cool. But basically, it's a Scrabble board. But just like my tile game, it's real time and scrolls infinitely. You just start placing tiles on other people's tiles, and it just keeps on going forever in real time. So you can go play this word squared. I'm not quite sure what the URL is. Okay, that's easy enough. Great. So this was me playing for 5 minutes this morning. I got 14 points. So that's all the slides. We have not much time left. Any questions? Yes?
Is Sencha planning on rolling Node.js into their package or software product?
I assume so. I don't know. I'm not working on that anymore.
What's a good resource to find out how to connect to C, make C calls?
There's some documentation on the website, which is less than perfect, but you should be able to get started with that. Generally, the V8 API, V8 is the engine that Node uses to execute JavaScript. The API for that is mostly documented in the header files of the project. So get a little dirty, but yeah, it's there, and it should be noted that the IRC channel is very active, and people will answer your questions if you go on there.
I left that off. It's node.js on Freenode. Another question? Yes?
I may not really know how to ask this question, but in playing with Node, I couldn't really figure out Node, Connect, and Express. How do I know when and how to set up a callback so that it does release? what are the rules for allowing that sort of, event-based architecture versus just having a long line of script where it just does this, does that, makes it
Yeah.
all.
That's actually one of the harder parts about event-based programming is your callback chains aren't as immediate. In blocking code, it's easy. This happens, then that happens, that happens. If you get here, the other stuff happens. In callbacks, you got to be careful when you're writing your code. In a Node HTTP server, if you don't call end, like you saw earlier, that connection will never close. The browser will just spin forever until it times out what's default, 120 seconds. And it's hard. I've got a few articles on my blog about various techniques of managing that. There's a ton of libraries out there. My favorite one that I wrote is called Step. It lets you say, do these 3 things in parallel. When they're done, do these things. When they're done, do these things. And it gives you somewhat of a control of once you get down to this line, you know these things have happened.
But I knew I didn't know how to ask it. What I was wondering is so you have your server and then get, and it throws a callback in, and it releases, and then later on the callback is called and is returned.
Yeah.
So if I'm going to write something that uses that pattern, how do I write it so that it releases and uses a callback versus just goes to the end and returns?
You have no choice, right? Everything in Node somehow has a callback associated with it. So if you access a database, you can't make a query and get a response without getting a callback, right? Somehow it has to be built on top of that socket library, which has a callback on data, which you're going to parse, and then you're going to get a callback. So you basically have no choice. You're going to be forced into that paradigm. There are no, say, accessing a database. There's no way to make a request to the database and get a response in one line, if that's what you're asking.
Well, the code inside the callback will execute all the way down.
It will go right through it will just keep going through the rest of the callback.
But there's not a way for me to implement that same pattern within there in custom code.
Sure there is.
That's what I'm asking.
Yeah. How do I explain it? It's the same as the browser. Code never stops. It goes from the top of your function to the bottom of your function. Your stack grows and shrinks, and your stack is gone. And when the next event happens, it's a new stack. Everything is one stack at a time. And so if you want to implement a function that's an async function, you're going to take as your last parameter callback. And somewhere in your code, you need to make sure that in all of your various logic cases, you eventually call that callback so that the function calling you will get their callback called eventually. And basically, you take a callback as your input, and somewhere you have to remember to call that callback, because if not, it's a broken link in your chain and the program just hangs.
So I think we're out of time, but after this, why don't we'll just stay up here and then we'll answer all of your questions, because I'm sure we have like 5 minutes or so, but let's not let the videos run too long. Okay, so thank you.
Thank you.